Welcome to Maths for You channel. A past question on integration and volume. The region enclosed by the curve y equals square root of x plus 1 divided by x squared plus 1, x equals 0, x equals 1, and y equals 0 is rotated about the x-axis through 2 radians. Show that the volume of the solid thus generated is pi by 4 times pi plus log 4, natural log 4. So just what they say is that the curve is y equals square root of x plus 1, x squared plus 1, and the region is defined. X equals 0, that is y-axis, x equals 1 as read it, as 1, and y equals 0, x-axis. Let's put a little sketch. The sketch is nowhere near correct, just for the visibility of what we are doing. A pictorial explanation is better. So it's just a curve, it's just any curve. So we don't know exactly how the curve will be. So I just put a little curve. That is, equation is y equals square root of x plus 1 over x squared plus 1. And the region is defined. X equals 0, that is y-axis, at x equals 1, it's in the dotted red line, and again y equals 0 at x-axis. So the region is shaded. This region is a two-dimensional region. When you actually rotate through 2 pi, another full cycle, if you rotate it, simply if you have a paper, if you rotate it, you get a solid. So solid with the reference to x-axis, of course. Yeah, when you rotate it, it will be a volume or three-dimensional object. So we need to find the volume. Area shaded to rotate about the x-axis through 2 pi, through 2 pi radians. Right, the volume. It's this type of question is a standard form. Volume is, as the students should know about it, the integral sign pi times y squared dx, and again the limit is given, so 0 to 1. So this is simple standard form integral property. If you find the volume, so pi y squared. Right. If you could take the pi out of the integral sign, so 0 to 1 integration, and y squared. Y squared means you just remove the square root, because y is the square root of x plus 1 over x squared plus 1. So just remove the square root, and then we get y squared, x plus 1, x squared plus 1. Now we can actually separate this quotient function. Pi equal integral 0 to 1, the first one x over x squared plus 1 dx, the second one pi times again 0 to 1 integral 1 over x squared plus 1 dx. Right. If you look at the first one, is we can actually manage to get the differentiation of denominator in the numerator. So differentiation of denominator in the numerator. Let me write it down. So differentiation of x squared plus 1 dx equal 2x. And if that's so, and we can get that integration. Anyway, so what I try to do, and if that's the case, integral of say 2x over x squared plus 1 dx equal log x squared plus 1. Right. What it is, it's a simple property of integration. If you have the denominator is the differentiation of the denominator, then the integral of the whole function will be the log of the denominator. So that is exactly what it is. So we have x squared plus 1. So differentiation of x squared plus 1 is 2x. But we only have 1x. So we can make it 2x and then divide. So we just multiply by 2, divide by 2. So this function, we can write it again. Pi over 2, 2x over x squared plus 1. So nothing changed. All I did, multiply by 2, and you have to divide by 2 to make the function same. Plus, and this one, pi 1 over x squared plus 1 dx. Right, again. So the first one is simplified already, that the denominator, the differentiation of denominator is in the numerator. Therefore, the integral of the whole function will be a log function of the denominator, a log of denominator. So pi over 2 log x squared plus 1 plus pi. Right, here, the next one, 1 over x squared plus 1, or 1 over 1 plus x squared, is a standard form, is tan inverse. So again, students should know about it. If don't, just look up. So pi by 2 log of x squared plus 1, pi, and 1 over x squared plus 1, integral of 1 over x plus 1 is tan inverse x. Right, now we can actually put the limits is 1 and 0, so we can apply the limits. So upper limits first, substitute x equal 1, pi by 2 log 2, x squared is 1, 1 plus 1 is 2, plus pi tan inverse x is 1, tan inverse 1, minus then 0 for, substitute 0 for x. So pi by 2 log, when you apply x square x 0, the x squared is 0, so only 1 log 1 plus pi by pi tan inverse 0. But log 1 is 0, and again tan 0 is 0, so that is tan inverse is 0. So that this part, the minus part, completely is 0. Those of you don't know about log 1 is 0, tan inverse 0 is 0, just look up. So what we left with, pi by 2 log 2 plus pi over 4. Then the actual question we have, we've been asked to prove pi by 4 something inside the bracket. So pi by 2, we'll have to take it out to prove the format they want. So pi by 4 out, if you take pi by 4 out, of course you have to multiply 2. 2 times log n 2, log ln 2 or log 2, plus pi by 4 out is only pi left. So pi by 4, 2, we can actually make it as log 2 to the power of 2, which is log 4. So 2 ln 2, that is equal ln 2 to the power of 2, that is equal ln 4. Ln 4 plus 5. That is exactly what we have been asked to prove as the volume when the shadow region rotates through 2 pi. Thank you. Please subscribe the channel and share these contents to other students, please. Thank you.